All right, so here we go. All right, to get your points, this is worth 9 points. You want to just start adding up your points that you want to get. I'm going to talk about what you would write down since it's a calculator active problem to get your points. You want to just punch it in your, you don't want to just punch it in your calculator and start writing numbers down. So you'll do your setup, but y'all are great at this anyway, so I can like stop that lecture because you're super good at writing down what you need to. All right, find the acceleration of the particle at time t equals 2. What is, and then I'll read the rest of it. I think it's a really good idea just to find something in the question that you can do and do that. Like the one where it was find the area between the graph and the tangent line that I did the other day. And by the way, whichever one I messed up with the regions and all of that, you may, I think I emailed you a copy of me doing it perfectly with whatever arithmetic I messed up. But anyway, I can find the acceleration. So what I want to say for my grader is I want to say, on the A part, I want to say that the acceleration is the derivative of velocity. So I'm about to find the v prime of 2. And you see how, I'll scroll down to the grading standards in a minute. You'll see how I'm getting points. You don't want to just do it. All right, now I'm going to put it into my calculator. All right, so I'm going to go to y equals, I'm going to put it in my y board anyway. I'm going to have a calculator active problem, so I'm just going to use x plus 1 sine of x squared over 2. And I'm going to check my mode, and I'm in radians. Okay, so now I'm going to go to math 8 and take the derivative in terms of x of what I have in y1. Remember to change what you have in y1 from problem to problem. Sometimes I forget to do that. And I want to do it at 2. Remember, if I wanted to graph the derivative, I could be doing this in my y board and have x at every x. Does that make sense to everybody? If you want to, and I'll graph the derivative or graph one well, I really want, but I might just for practice. I want it at x equals 2, and so you get that right, 1.587 or 1.588. Either one of those is acceptable. So I'll just put 1.588. All right, now it said, is the speed of the particle increasing at t equals 2? Why or why not? Many times it will say, is it increasing or decreasing? Please don't base it solely on velocity or solely on acceleration. Some people go, oh, well, my acceleration is positive, so the speed is increasing. That might not be true. If you have something that's falling and you're pulling back on it, you might be slowing it down. I heard in finance class, or whatever it's called, the Lindbergh class, y'all were talking, who's in that class right now? Dr. Cornelis. Whatever article someone was talking about, or whatever, he said that it was increasing at a decreasing rate. The money somebody was making, or the
that was my class.
Yeah, and so things that are increasing, like this is increasing at an increasing rate, but now it's still increasing, but it's at a decreasing rate. Do y'all see what I mean? Okay, and so this is a positive first derivative and concave up. They're both positive. Whereas this is still a positive velocity, but a negative acceleration because it's concave down. So if you have different signs, it's slowing down, it's not speeding up, okay? So you always, if somebody says, is this slowing down or speeding up, you always want to check both the velocity and the acceleration at that point. So now I'm going to also tell the grader that I found v of 2. You don't even really have to find it if you don't want to. I mean, you can, but if I fill in v of 2, I'm going to get negative 3 sine of 2. Now, granted, a lot of you don't know what sine of 2 it is. But I don't know what sine of 2 is, like numerically, but I know it's sine, S-I-G-N. 2 radians would be in what quadrant? You know, it's funny as you deal in parts of radians so much, like pi over 4, you forget where 1 radian is. 1 radian is about 57.3 degrees. 2 radians is in the second quadrant where sine is what? I always want to give you the wherewithal to think about this in case it's a non-calculator problem, okay? And think about it. Don't y'all know that this is 3.14 radians?
Yeah.
So I know sine is positive in the first and second quadrant. Or you're free just to type it into your calculator's calculator active problem. But I would tell my grader that b of 2 is less than 0 and a of 2 is greater than 0. And so the particle, the speed is not increasing, and this would be my reason. So for the bit, I would actually write it down. I would say not increasing, and that justifies your answer if you can read my writing. Show them that you tested the velocity and the acceleration. It's so tempting if something has a positive velocity or a positive acceleration to think that it's increasing. There's a problem, and I'm thinking in my head that one day you'll see probably where it asked if the speed, I think of a skydiver, and the problem was increasing or decreasing, and they had a negative velocity, obviously. But they had put a parachute somewhere in the problem and told you what it did. And so a negative velocity with a positive acceleration will slow you down, okay? Why do we speed up if we just are totally left unattended, if we drop something or we fall? Why does our fall speed up until we reach, because accelerations, yeah, until we reach terminal velocity. That's the word I was looking for and I couldn't think of it. It's actually in that problem. But acceleration is negative 9.8 meters per second squared. It's always pulling down on us. And then if you're dropping something, you have two negatives, which is speeding it up. Are y'all okay with that? All right. Now, what would a graph look like while I'm kind of teaching about this with two negatives? It would have to be decreasing and concave down. Do you see how that would be speeding up? Okay. Whereas if it's decreasing and concave up, it would look like this. So can you see that would be slowing down? And my slopes would tell me about that, okay? Along with my first and second derivative. So moving on, stop me if you have a question. All right, now find times t in the open interval from 0 to 3 when the particle changes direction. I think to myself, what has my teacher taught me about when a particle changes direction? Your velocity or your first derivative has to change. Now if I scroll back up, it tells you this particle's moving along the x-axis. So if it's moving in horizontal motion, we talk with velocity left, right, left. If it's moving up and down, we talk up and down, okay? Increasing it, I'm sorry. You think it's going up and down like this, but many things are going across. We'll study this more later. But I thought, well, I need to know when the velocity is 0. So I'm gonna make myself a note. I need to know when the velocity is 0, and then I need to test the signs, okay? So I'm gonna go back to my calculator, which always seems to disappear. And it's in y equals, now what's in y1? What function is that right now? Velocity, which is the first derivative. So right now I'm doing a first derivative test to see when something changes direction, okay? So if my velocity is positive, I'm doing this. If my velocity is negative, I'm doing this. Do y'all see what I mean? Okay. All right, so I'm gonna make my window from 0 to 3. They're great at telling you a window. Many times when I just wanna do a sign chart, I don't care about negative 10 to 10. So just kind of follow my lead of what I'm modeling when I do some stuff on the calculator. I'm going to use their window that they gave me, their domain, because I don't need to worry about all the other stuff. And also, if I just want to know positives and negatives and zeros, I sometimes want to come in a little bit. I'm always in control of my window. I never hit zoom in and zoom out. Okay? And you're not going to want to, because you probably all lost your graph somewhere before. Okay? So be in control, and then I'm going to graph. And so now I see I have a place where it changes direction because my velocity went from positive to negative. And so I might want to go off to the side of my scratch. This doesn't count as proof to them, but it gives you something to say. Didn't your velocity go from negative to positive? You can't just leave that as proof though. But this does tell me that the particle is going left and then right. And so it changes direction at whatever that point is. So now I'm going to go back and in interest of time, I'm not going to do it right. Well, I am, because I need to show you something. So I'm going to go to second calc 0. I'm gonna move over a little closer and enter, go a little further, enter, and I get 2.5066. Right then, I'm gonna quit that screen and hit X, and I'm gonna store it. And just in case I needed it later in the well, I didn't have to store it on our fancy calculators, because you can on almost all of the calculators you have, you can scroll back up and grab that number. But sometimes I've done a lot of work and I don't wanna go.
So what did you do? You just hit X?
Yeah, as soon as you do calc intersect or calc zero. You have to do it as soon as you've just done it, okay? And you can quit that screen and hit X and just verify that you have the number you want. And then if you want to, you can store it for a variable. Don't start calling it A on your paper though. They won't know what you're talking about unless you say A is equal to 2.506, okay? And so now I'm not using a rounded number, I'm using a good number. All right, so let's answer the question. Find all times in the open interval when the particle changed direction, justify your answer. All right, so it changes direction. I'm not gonna try to write all these words right now. T equals 2.506 because V of T equals 0 and changes from what? Your velocity changes from negative to positive, okay? I mean, obviously you would write it neater than that, but I'm in a hurry, okay? And by the way, a lot of people don't write it neater than that, but we can still read it. All right, so is everybody okay with that? If they said, when is it moving to the left, what would you say?
From 0 to...
Great, not negative infinity to 2.506. You would say 0. Do you see what Carla's doing? So make sure you're talking within only your domain, okay? Grace?
Well, one thing I did a different way for part B, and what I just thought about was like if I looked at the equation, what would make the equation 0? So if sine of t squared over, I thought about like sine of t squared over 2, and I know that sine of pi is 0, so I just solved if t squared over 2 is equal to pi, then instead of like having the decimal I had just the square root of 2 pi.
Awesome, this is what a reader sees. Great, yeah, this is what a reader sees. I'm glad you brought that up, because if I was grading it right now, I'd have this sheet in front of me. So let's go and look at the first two. Do you see how if you get a point for stating all of this right here, and then explaining that the speed is decreasing and why. Do y'all see how I did all of that? Don't just like start writing stuff down. Then they did what Grace did. They actually used like kind of a U sub and solved for, they found it in exact form, but you're also welcome to use 2.506 or 2.507, but I have to state I'm looking at where my velocity is 0, and do you see how they're saying that it's less than 0 from 0 to 2.506, so you got to get all of that in for your points. We weren't required to take the square root of 2 pi, but that is 2.506. This is a calculator active problem. But it sounds like a couple of y'all just did it without a calculator. Don't forget you have one, so be careful, okay? You could double check it. Everybody okay there? I think the girls, and then I guess you did a sign chart and thought about your positives and negatives or something, okay? All right, now the total distance traveled, you have two choices. What you never want to do, ever. I'm going to erase this since it's on the screen. All right, so you have all that information, and what you never want to do if they say total distance traveled is integrate it from 0 to wherever, or -5 to 8, or whatever it is they're asking you, okay? Listen carefully. You never want to find area, total distance traveled, volume, or any of these things without looking at a graph. I love seeing all your graphs on your paper, okay? Because it might have changed direction. If you just integrate it straight from 0 to 3, if you integrate velocity, you're going to get distance, okay? If you integrate that straight from 0 to 3, you're going to get displacement, which we talked about a lot. Are y'all okay? You don't want that. okay? The only time you should be doing that if you know it's entirely going to the right the whole time. If your velocity showed you that, then you can do it. But to be on the safe side, if you have a calculator, you can throw in absolute value and be guaranteed you're gonna be okay. I think it was 4.333 or 4.334, that I would take truncated or rounded. Okay, so you can always do that if you have a calculator, but girls, what if you don't have a calculator? Okay, I would know that it went from the left from 0 to 2.506. Now time out. If you didn't have a calculator, you probably would have factored in, it would be more of a normal number. Okay, not an irrational number. Do y'all see what I mean? Okay. If it's going to the left, I better make that negative of my velocity. And then add on the part that it went right for the rest of the time. On some of your quizzes, I had to point an arrow up to, wait, this was underneath the graph, okay? So do y'all see what happened here? If you integrate it from 0 to 2.506 of the velocity, you'll get a negative answer that you want to make negative because you want to add it up. That's how far it went to the left. So do you see why I negated it? Okay, so I could do either one. And to model that for you, I'm going to go to Math 9. I'm going to go from 0 to A of what's in Y1. By the way, it's not the way I would work the problem myself, I'm just showing you. Because you might have to do this on a non-calculator problem. Alright, so do you see I want to get that distance, negative 3.65? Alright, so I'm going to negate that answer. And then I'm going to add on the integral from A, don't call it A, on your paper you'd write 2.506, to 3. Of what we have in Y1. Be careful you're pulling the right thing in, dx. And so do you see we get 4.333 or 4.338? If I have a calculator in my hand though, I'm obviously going to just go to anything they give me. Math 9 from 0 to 3. If I have a calculator in my hand, I'm not going to do that. I'm going to go to math, number, absolute value, whatever that is. Math, number, abs, bars, y bars. Putting an absolute value, even if it's always positive, is never going to hurt anything. Okay, Emma?
No.
Okay, so I would do the second one. Looking at the grading standards. Do you see that? So what we would expect you to do that if you're handed a calculator and in a good calculus class. If you didn't do that, they would have already talked us through in our little pre-grading session that we have before every number that we grade. They would tell us we'd be taking frantic notes of what else we could accept. If I didn't take notes of it in the grading section, you would definitely ask the person sitting next to you and go to the head grader with it, and they'd say, okay. I mean, that'd be fine for you to break it up into 2, but we'd be going, why that student do that at a calculator? Okay, just wasting my time. Which, by the way, y'all are doing a beautiful job of answering free response. One of the best I've had as far as your notation and everything. The reason that's important is because it communicates to anybody on the college level. It's very, the college board keeps in mind what's happening in colleges. So it's a nice segue into whatever you go to. It's very clear. And also your grader's really happy grading the problem. Because it's what's expected. Yeah. I mean, hopefully I plow away. I'm like, oh my gosh, what are they doing? Where'd they go? But it's really nice to just grade a paper and turn it over and go, they did, they did. Okay? The good news is if I'm grading somebody's number 2 and they're really aggravating me, I don't usually have their number 3. I grade number 2 all morning long, and then you get trained on number 6 and grade number 6 all afternoon or whatever. get to be like really good at it. So the good news is somebody's not, I maybe shouldn't have told you that though, because I want you to think of somebody flipping your paper that you want to make happy. So, yeah. So anyway, you want each grader that looks at yours to be very happy with your paper. Okay, now, this is what Grace has really been wanting to see here, and so I hope have you. When I read this, I was like, you know what, if I was a student, hopefully I would just be very literal, like like I keep telling you, or also, maybe you wanna, if you're at the end at 2D and you've done everything you can do, you can't even look at the other ones till they call time, and then you can get out 3, 4, 5, and 6. So, if you had other things to do that you want to go back and look at, you might want to go make your point somewhere else if one of these confuses you. Because at that point, not on one of my tests, but on the day of the exam, you're trying to get all the points you can get. However, this is very doable based on what I've taught you. And that, how do you find the greatest anything? Somebody the other day asked me about optimization, because you may hear some classes doing optimization problems, like what's the biggest box you can make or something. Well, if you want to make the biggest volume, you want to take the derivative of volume. So we don't really hammer away on optimization problems. But if I say the greatest block, you need its derivative, okay? So how will I logically know the greatest distance between the particle and the origin? Here's what I did. I didn't like this question either, Grace, but I have to do them, okay? During the time interval 0 to 3, I'm going to stay there. What is the greatest distance? And I read it and went, what? So I went back and I thought, what word can I look at? Always look for a key to unlock, okay? Greatest distance. That's the derivative of distance. Oh, that's the velocity, okay? So now I remember I've already done some work where it went left and came back right. So now my question is, what scenario do I have here? Y'all might remember the graph of it, so you probably already have a supposition. Did it go further left or further right? Or the same? Based on what you know today, not when I gave you the problem originally, I wanted to just sort of see what you thought about it, but based on what you know today, do you think it was further left or further right? It went more to the left, but we have another problem. It kind of depends on where it started, because it said the greatest distance from the origin. So I also have to think about, where is the origin in this picture, okay? If the origin's over here, then I don't care how far left it went, that's the greatest distance. Do y'all see that? I also have to wonder where the origin is. Okay, you know what I wanna know? I wanna know where that thing is. So couldn't I integrate velocity? Alright, so I'm gonna integrate velocity. I'm doing the fundamental theorem of calculus. I'm gonna integrate velocity from 0 to 2.506 and watch what it'll give me. It'll give me s of 2.506 minus s of 0. They never called it s in this problem, so whatever I'm calling distance, I'll define it for them. Okay? Why did I just go to 2.506? I know that's where the particle what? It turned, didn't it? Okay, so here, let's say here I am, and that's the origin right there, that white block. All right, if I go left, and then I go right, do you see I'm still wondering how far away I am from the origin? So I want to know, where am I at 2.506 before I turn? Do you see my reasoning behind that? Okay, so in interest of time, I'm just going to tell you what I got here. I got negative 3.265 is equal to s of 2.506, and what was s of 0? Look at the problem. S of 0 at t equals 0, where was the particle? At positive 1. So it was at positive 1, and if this is the origin, you started right here and went this far. So s of 0 is 1, and so s of 2.506 is equal to negative 2.265. Girls, I know now how far that is from the origin. I put in the initial value of 1, and I found out that at 2.506, I'm negative 2.265 away from the origin. But then what did the particle do? It moved where? left, and then what did it do? Then it moved right. Don't I wanna know how far right it went? Okay, because if I find out that at S of 3 at the end, that it was at 5.869, then I know that that's the furthest from 0, okay? So I integrated it from, let's see if I wrote down the numbers though, because they didn't do that in the solution, but I did somewhere, okay. So I integrated it from 2.506 squeeze it in here. So I integrated it, and it's very logical if you think about it. It went left, and it went right, and the origin is right here. It started at 1, okay? And so I integrated it from 2.506 to 3 of the velocity. That gives me S of 3 minus S of 2.506. And when I did that, I got 1.608. Like, let me see if I can explain it better, what I was thinking. Okay, so this number right here was 1.608. So what is that 1.608? That's not where it is. Right now, I just integrated it from 2.506 to 3. I haven't done anything with the right-hand side. Very good. That's just how far it moved to the right. It moved to the right 1.6. Okay? So did it even make it back to 0? Because you're at negative 2.265. So I would say the greatest distance from the origin is 2.265. Okay? So I found out where it was when it turned, and I found out where it was when it stopped. And if I found out it was way over there when it stopped, I would have to say the other number. Y'all see the reasoning behind that? Okay? All right, let me show you what they did. It's very similar. And this is really cool what they did. They integrated it and got negative 2.265 for S of 2.506. And they said, wait, but we already know the total distance traveled is 4.333. And so the part that's left over, they would still be, if you subtract those, you would have gotten the 1.608. So if you know that you've already moved 2.265 away from the origin, and the whole total distance was just 4.3, do you see you would have never made it even back to the origin with what's left over in your distance? I kind of like what I did better, but anyway. All right, now let's chop up food. Girls,